This is 7th grade lesson 5.7. The objective today, students will use their visual skills to draw and identify rotations in the coordinate plane. The standard covered is 8G3. The page numbers out of the hardcover book are pages 232 through 237, and out of the practice journal, pages 131 through 134. You will also need 5-7 worksheet, which is in the folder over on the counter. Okay, today we're going to be working with rotation. So far we've worked with two different forms of transformations. The first one was a translation, which was a slide. The second one was a reflection. So that's where we flipped our figure over a line of reflection. And today we're going to work with rotations. A rotation or a turn is a transformation in which a figure is rotated around or about a point called the center of rotation. So here our center of rotation, oftentimes we'll use the origin if we're working with a coordinate plane, but it's any point that the figure rotates around. The number of degrees a figure rotates is its angle of rotation. So here, the angle of rotation, we would have to go through and actually measure the angle measure of that angle that's formed between the original and the new figure. The original figure and its image have the exact same size and shape. So you'll notice that these bikes are exactly the same. It's just that it has rotated or started to turn around that center of rotation. Okay, another piece that goes along with this lesson is just a little bit of vocabulary, and that's working with what they call rotational, or sometimes referred to as radial symmetry. And radial symmetry or rotational symmetry happens if a rotation of 180 degrees or less produces an image that fits exactly on the original figure. So these are two figures that involve rotational or radial symmetry. So I'm going to draw over really quick, especially this first one, so that you can see there's actually kind of a triangle that's produced in here. So radial symmetry is if I were to take that little piece of this pie and rotate it, would it land exactly and look exactly the same? So if I look at that black triangle-ish pie piece versus this yellow one, do they look exactly the same? Well, no, they don't there. So if we continue to kind of look at the next one over, we can see that our black and our blue are exactly the same. The red is in the same spot. The white little portion is in the same spot. Okay, so the black and the blue would show rotational symmetry. If I were to rotate that around, it would land eventually back on top of another piece that's exactly the same. If we were to go ahead and look at this next one, okay, we would see that our purple and our yellow are showing rotational or radial symmetry. Okay, same thing on our other figure that's over here, our hexagon. If I were to trace over the lines of this, we've got a triangle there. If we were to rotate that around, would our other triangle look the same? So if I were to extend this out and just focusing on the blue triangle versus the yellow triangle, are they similar to each other? Well, if you rotate that around, yes, they look a lot alike, but you'll notice here we've got red in this corner and here we don't. So let's go ahead and look at the next one. If I trace over this, okay, we can see that this one that's up here looks like my green one that's right here. So there I'm seeing rotational symmetry. It lands exactly in the same position. The colors are the same and in the same positions. Although, had that not been colored, the image, all of those shapes that are in there are exactly or look very similar to each other, but it kind of looks like it's rotated a little bit differently or flipped. Okay, there looks like to me like there's a reflection right here. See how this and this are the same? Okay, so rotational symmetry is when we take this blue triangle and we rotate it about this origin. Okay, it lands in the exact same position there. So that's just introducing you to some vocab that could possibly be showing up on STAR or Iowa assessment. Just kind of had the opportunity here to kind of review through that. Okay, so what we're going to be doing is we're going to be working with understanding when we come across a rotation. So when I assess you on rotations, I will be giving you images and asking you to identify whether or not a rotation has occurred. So we're going to practice that concept right now. So here I have a coordinate plane and I've got 2 arrows. The key thing is when I'm checking for a rotation, when rotating an image on our coordinate plane, if we pick a point, we need to make sure to keep the same distance from that center point when we create our image. So for example, here, if I look at this red arrow, if I was converting from the red to the blue arrow, I should be on that axis line, and I should be, it looks to me like 3 boxes away at the bottom. Okay, so let's look. Am I on the axis line? Yes. And then to the right of our image, so to the right of the long part of our image, did I have 3 boxes? Yes, I did. So this would be considered a form of rotation. We have the exact same shape. It's the exact same size. It has rotated 90 degrees around the origin. So this is our origin, our very middle. So this does show a rotation. Okay, so key thing is making sure that it's in the same position on the other set of quadrants. So here I have 2 hearts. So if I were to take those 2 hearts, we'll look at the red one and see. So if I look at the red one, it looks to me like it's a little past a box from that access point. And then the edge of it is within that last box there. So am I a little over a box here? Yes. I've got a little over a box there. I also have a little over 2 boxes there, a little over 2 boxes here. So yes, this would show rotation. It rotated 180 degrees. Okay, if I were to take this image and turn it, you can see where each of those is positioned. If I were to take this image and rotate it, they're going to be in the same positions. There's a 180 degree turn. They're in the same positions. Okay. All right, let's try one more. So let's look at our triangle here. From red to blue, does that show a rotation? So I'm going to identify, well, I've got a point right here on my axis line. Do I have a point on my axis? No, my 2 points are not touching the axis line, so this would be a no, it does not show a rotation. What type of transformation does it show? It shows a translation, a slide from one spot to another. Okay, so now what I'm going to do is I'm going to go ahead and bring out 3 sets of figures, and we're going to identify those figures as either rotations, translations, which is a slide, or a reflection, which is a flip. So what I want you to do is I want you to go through, pause your video, and see if you can identify of these 3, which one's a translation, which one's a rotation, and which one is a reflection. Okay, so here I'm noticing between the 2, that is a reflection. So for A, it was a reflection, taking note that it flipped over that axis point. On B, here's an axis line. It looks like it was rotated or turned on its side, so this would be a rotation. And for C, there's our axis point. It looks to me like it was just slid over to the other side of that line. This would be a translation. Okay, so when I am assessing you over rotations, it would be an example like this where I would give you some pictures and ask you if it was a rotation or not. I might ask you to identify some of the other transformations, okay? But for today, what we're gonna do is we're gonna actually practice just creating rotations. This is a very hard concept. Some of you will pick up on it very easily. If you're a visual person like me, these are kind of hard to do because I like to physically see it or be able to physically touch and rotate it. And when it's on paper, it's hard to do that. So what I've done is I've taken a copy of this grid and I've noticed that I have the exact same thing without the bottom portion. What we're gonna do is we're gonna go ahead and do a rotation following what they would like us to do. Okay, so here we're gonna go ahead and rotate 180 degrees counterclockwise. So we're gonna review really quick what clockwise versus counterclockwise is. So Counter or clockwise is when you go around a clock and you count the numbers in order. You move around in this direction. Okay. Counterclockwise is when you do the opposite. You go around backwards on your clock or counter, and we're moving in that direction. So this is counterclockwise and this is clockwise. Okay, so now what we're going to do is we're going to go ahead and follow the direction. So 180 degrees. So what does that mean? Well, let's think in terms of we're just going to do 90-degree turns. If you were facing the front of the room, a 90-degree turn would turn you like a fourth of the way around. So you would face the other wall, like a wall right next to you. Okay, if you were to do a 180-degree turn, you would turn completely around facing the other direction. If you were to do a 270-degree turn, you would turn 3/4 of the way around. Okay, so if I was facing the front of the room and I wanted to do a counterclockwise turn, I would counterclockwise 270 degrees and I would then be facing the window in my classroom. Okay, 360-degree turn is a complete rotation, and you guys won't be working with a 360-degree turn in this lesson. We're going to work on mainly 180s and 90s. Okay, so here they want us to rotate this figure 180 degrees. So I'm going to take my image that I have here, and I'm going to rotate this 180 degrees. And it said counterclockwise, so I need to go this way against what the numbers are on the clock. So there's a 90-degree turn. There's a 180. Okay, so now when I go to draw this image, it's going to sit up in quadrant 2. Okay, so let's go ahead and just transfer that over. Okay, some people are very good at, they can visualize and see exactly where it's going to land and how it should look. I know that that's hard for me, so I tend to like to physically turn my paper if I'm working on my own. Here on my smartboard, I went ahead and copied it, and then I'm just rotating that part of the figure. Okay, so if we look at this, the key thing is if you're trying to do this without physically rotating the paper, you're going to see that here's our access line right here. You are one box away for those two off of the access line. So in other words, let's see, from our origin, this is our origin, remember, we were 5 places away. So we're going to go 5 places away from the origin and then in a box. 1, 2, 3, 4, 5 in a box. There's where my red dot currently is. And you'll see it's also right here. Okay, then I sometimes will just transfer. I know that my next dot is going to be my green dot. Looks like it's 2 boxes further away from the origin. So 2 boxes further away would be right here. Okay, so you can go through and transfer them that way. Or if you are somebody that needs to physically be able to turn the paper, when you guys go to do your homework portion, I do have copies of the side B figures that you can grab during class, and you can actually physically rotate them and be able to just transfer by looking at it here and then transfer it over into this figure. Okay, rotations are very difficult. They are hard to go through and do. Okay, so we're going to go ahead and finish out drawing this out. So I'm noticing that my blue is straight up or away from my green. So I'm going to go all the way out to here. So there's my blue figure or point. And my yellow point, if I go down 3 boxes and then back 2, so down 3, back 2, there's my yellow point. So here's my figure. Making note that it makes the same shape. It's just a shape that has been turned around that origin or rotated around that origin. Okay, so we're going to go ahead and practice another one of these. Now you should be doing these on your front side, your side A of your worksheet as I'm working through these on the smartboard. It's just good practice. Okay, it gives you a chance to kind of double check yourself to make sure that you're understanding it. So number 2, we're also just going to work on the rotation part of it and not worry about the coordinates. We'll do that in numbers 3 and 4. Okay, so for number 2, it says the shape above has the following coordinates. So it lists our coordinates, and rotate the shape 180 degrees counterclockwise. So we get to do the same thing, counterclockwise against the numbers on the clock. So there's 90, there's a 180. So once again, we're going to end up in quadrant 2 again. Okay, so for those of you that like to count it out, you don't need that visual that I have on the left-hand side. Well, to get to our red point from the origin, we went down and to the right 1. So if I'm going 180 degrees, I'm going the exact opposite. I'm going to go up 3 and to the right 1 and put my point. Okay, so there's where my yellow or my red dot is. Okay, then I can go through and either follow to move away, or I could continue that same manner to do this method. So if I wanted to get to my green point, it looks like I'm going to go down all the way to 10 and then over 1, 2, 3, 4. So from my origin to get to the green point, I'm going to go up 10 and over 4, 1, 2, 3, 4. There's my green point. Okay, and then to do the yellow, I can still follow the same concept. Looks like we're going 1, 2, 3, 4, 5, 6, and then over 5, 6, 7, 8. So I'm going to do the same thing. I'm going to go up 6, 1, 2, 3, 4, 5, 6, and then over 8. So there's 5, 6, 7, 8. You'll notice on my screen that every 5th line is a little bit darker. It doesn't show up as well on your paper, but it does help you to count them out. So now you can see that my figure does look the same. It's just rotated around the origin. Okay, remember the origin is our very middle. Okay, so that's working with rotating it around. So now we're going to go ahead and continue and do 2 more practices off of that. Now, if you're somebody that the concept that I just did on this side where I count out in a way, if that's difficult for you, on a 180, it's pretty easy. On a 90, it's a little more confusing. Then you can physically just grab these pieces when you go to do your practice work and just actually take them and rotate them around, kind of like I'm doing on my smartboard right now. Okay, so let's go ahead and do the third one. So this time what we're going to do is we will include our coordinates just to practice that coordinate counting. Okay, so here we have this shape that has the following coordinates. So our coordinates are over to 2, down to -2. So this is my A. My B is over to 2, down to -8. This is B. C is over to 10, down to -8. So this is C. That means this is D. Okay, so we're going to go ahead and rotate. This time on your worksheet, this may still say 180. In case I forget to change it, we're going to go ahead and do a 90-degree counterclockwise just so that we can practice something other than a 180. Okay, so I have 90 degrees counterclockwise that I want to rotate this. Okay, so 90 degrees counterclockwise is this way. Okay, and now on a 180, it's not going to matter if you go clockwise or counterclockwise, you end up in the same position. But if you're not doing the proper clockwise or counterclockwise on any other one, it's going to end up putting your new image in the wrong spot. Okay, so now I can physically see what it's supposed to look like. So on my 90 degree, from the origin, I went away 2 and I stayed right on the line. So I'm going to go away 2 and stay right on the right line. So there's my new A. Okay, so for B, it looks like I went away 2, 4, 6, 8, and off of the axis 2 places. So 2, 4, whoops, there's 5, 6, 7, 8, and then 2 places. There's my new green. And some of you are just going to physically look at this one and you're just going to count it off of this. You're going to say, I'm going to go over 2, then I'm going to go, and you're going to count it off of the one that you physically see because you're doing that physical rotation of the little slip of paper. Okay, so now when I go to do, this was my B, when I go to do C, well, that's going to be straight out from my B, and it's just, what, 1, 2, 3, 4, 5, 6, 7, 8 places away. So out to the 10th spot for my blue spot. There's my C. And then my D, well, my D, if I go from C, I can either go from C and count it off of this, or I can continue that method that I was doing. Well, from the origin, I went 3 places down, so I would go 3 places out here, like this. And then I need to go out to the 9th line, so right there is my D. Okay, so now you can see that we've got the image. And when I draw mine, it should look like what I have over on the left-hand side here. Okay, do those match? Yes, they do match. Okay, so you have to decide right now what you're comfortable with. This is a very hard concept, so please don't get too stressed out about it when I assess you on it. I'm not going to assess you on having you draw them. I will give you two figures and ask you if a rotation has occurred, okay? So for now, we're just practicing the concept so that later on as we move into high school classes and we have to start doing more rotations, we're at least have a little beginning of it. Okay, so let's go ahead and try one more. Oh, I forgot to do my coordinate sets on this one. So my coordinate sets of my new figure, well, for 3A, on your side of your right side of your paper, you have a 3A. Well, the coordinates of that were over to 2 up to 0, so 2, 0. 3B, well, that's going to be over to 8 up to 2. Remember, it's always over then up. 3C, once again, still over to 8, and we had to go up to 10, so that's positive 10. And 3D was over to 3 up to 9, so 3, 9. Okay, practicing writing those coordinates. Okay, so we're going to go ahead and do one more. And once again, when you go to do your independent practice, if you need little slips like I'm pulling these out here, you can go ahead and grab them out of the folder. Okay, so here's our last one. So I'm going to identify of my marks here, which is A, B, C, D. So over to 3, down to -2, this is my A. Over to 1, down to -7, this is B. Over to 7, down to -6, this is C, and this is D. Okay, so we're going to go ahead and rotate the shape 270 degrees clockwise. So once again, I have to make sure I'm going the right direction. And I'm going to show you on this one, if I go the opposite direction, it's not going to end up in the same spot. So we'll do the first way, the correct way, and then I'll revert it back to this. So if I were to accidentally go counterclockwise on this, so 270 would be like 3/4 of a turn. There's 1, or 90, there's a 180, there's a 270. So take note, it's sitting down in this third quadrant. Okay, so let's revert it back to where it was. Okay, so if I accidentally go counterclockwise, we end up here. Okay, so if I go clockwise, which is what I was supposed to do, is it still going to end up in that same position? There's a 90, there's a 180, there's a 270. See how we ended up in different spots? We really need to be in this quadrant right here, which is quadrant 1. So you have to make sure that you're paying attention. Am I supposed to go clockwise or counterclockwise? Okay, so now we can go ahead and transfer this out. So if I'm going to do my A, well, my A was what? 2 positions away from the line and then out 3. So we're going to go over 2. Change the right color. Over to 2, up 3. So there's my new A. Okay, so for B, which was my yellow, that's straight away from A. So straight on. And it was ended up being on line 9. So there's B. Or sorry, that was D. I just transferred my yellow. I meant to do that. Okay, so if I'm going to do the B, well, here it's out, what is that, 5, 6, 7, and then up 1. So we're going to go out 7, up 1. Oh, whoops. Okay, so there's my green one, which was B. And then letter C. So it looks like out 6 and over 7. So out 6, up 7. There's my C. So now if I go through and I connect these, they should look the same. Okay, so there's my image. It's not the best, but does it look like this one over here? Do those match up? If I were to slide this over, are they in the same position? Yes, they are. So I did a pretty good job with that. Okay, rotations, they're very hard. If you're a visual person like me, it's hard to visualize like what it's gonna look like without physically seeing it. So for those of you that need that, I do have those papers where I've just cut around, kind of like I did here on the smartboard, where you can physically take and turn it so you can see what it's supposed to look like, okay? So keep plugging away at this. The key thing on this is to just make sure that you're giving it your best try. A rotation is going to keep your shape the same shape. It's going to keep the same size. It's just going to rotate about or around a specific point. So on your worksheet, you're rotating around the origin.